All right, we're about to go on an absolutely epic journey. We're talking millions of years, from the fiery heart of our planet to the bottom of the ocean, and then all the way back again. Why? Because today we are digging into the incredible life story of a rock.
Have you ever just picked up a stone on a walk? It feels so permanent, right? So unchanging. But what if I told you that every single rock has a story? And it's usually a really dramatic one, full of birth, conflict, and total transformation. Just take a look at these two. On the left, you've got granite, with its whole mix of dark and light specks. And on the right, there's a piece of quartz, which looks way more uniform, almost pure. They feel completely different. But why? What actually makes one a rock and the other a mineral? To get to the bottom of that, we have to start with the absolute basics, the fundamental building blocks of our planet's crust. It really all comes down to the difference between a rock and a mineral.
Honestly, the easiest way to think about it is like baking. Minerals, they're your individual ingredients, the flour, the sugar, the eggs. And rocks, well, they're the finished cake, where all those ingredients have been mixed together. So a mineral is pure. It's a solid that's made of just one single component. And that purity is what allows it to form these beautiful, definite crystal structures, giving it a very specific geometric shape. Quartz is the perfect example of this.
A rock, on the other hand, is kind of a mashup. It's a mixture of a bunch of different minerals all smushed together. And because it's a mix, it doesn't have a neat, definite shape like a pure mineral crystal does. That piece of granite we saw? A classic rock.
Okay, so now that we've got that foundation, we can finally begin the story. And like any good epic, this one starts with a whole lot of fire, deep, deep within the earth.
Miles below our feet, the temperature is insane, skyrocketing to over 5,000 degrees Celsius. That is hot enough to melt solid rock into this thick, gooey liquid we call magma. And when a volcano erupts, that superheated magma bursts through the surface and becomes lava. It's a really simple but incredibly powerful three-step process. Rock melts into magma, it erupts as lava, and then bam! Exposed to the cool surface air, it rapidly solidifies. And that creates what we call an igneous rock, a rock that is literally born from fire.
And the results are just breathtaking. These massive formations of basalt, just like the granite we saw earlier, are igneous rocks. They are forged from cooled lava, and they're incredibly hard, marking the very first, very dramatic chapter in a rock's life.
But no sooner is our rock born than it has to face its lifelong enemies, the forces of nature. The process that breaks rocks down is called weathering, and trust me, it can be powerful enough to split a giant boulder, which is exactly what this tree root is doing here.
And this assault comes from all sides. You've got chemical weathering, like acid rain slowly dissolving the rock's surface. There's biological weathering, from the quiet work of plants and lichens. And then there's the most relentless of all, physical weathering, the constant grinding of wind and water, and the immense power of ice freezing and expanding in tiny cracks. But all those tiny, broken pieces of rock don't just vanish. Nope, they embark on the next phase of their journey, where they get reformed into something entirely new.
So first, weathering creates these tiny fragments called sediments. Then wind and water act like a global transportation system, carrying these pieces away and dropping them off in places like the bottom of a river or the sea. And over millions of years, layer builds on top of layer, and the incredible weight from above compacts these loose sediments into solid new rock. This is how we get sedimentary rocks, and they are basically history books written in stone. You can literally see the distinct layers in sandstone, showing how it was built up over time. And in limestone, you can often find fossils of ancient sea creatures whose skeletons were compacted right along with the sediment, telling us a story of a long-lost world. But the story still isn't over. Sometimes, through massive geologic events like earthquakes, these igneous and sedimentary rocks get shoved deep, deep back down into the earth, and that leads to the most dramatic transformation of all. Way down in the crust, the rock isn't quite hot enough to melt all the way back into magma. Instead, the combination of intense heat and crushing pressure literally cooks and squeezes it, fundamentally changing its entire internal structure. This incredible transformation is called metamorphosis. And the results are just astonishing. A sedimentary rock like limestone gets transformed into elegant marble. An igneous rock like granite gets squeezed and reformed into a completely new rock called gneiss. It's the same raw material, just completely rearranged by these immense forces. I mean, just look at this piece of schist. You can literally see the story of its transformation written in those wavy, distorted bands. It's a visual record of the intense pressure that bent and folded the very layers of the rock itself. It's amazing.
Okay, so we've seen rocks born from fire, broken down and reformed into layers, and then totally transformed by pressure. But here's the wild part. This isn't three separate stories. It's one single continuous cycle.
This diagram here shows the whole picture. An igneous rock can be weathered down into a sedimentary rock. That sedimentary rock can get pushed down and transformed into a metamorphic rock. And that metamorphic rock, it can be pushed even further down until it melts back into magma, ready to start the whole cycle over again as a brand new igneous rock.
This little cartoon recaps the whole journey perfectly. A rock is born in a volcano, gets weathered down and washed out to sea, then it's buried and squeezed under pressure, and eventually it melts, ready to be blasted out of a volcano once more to begin the whole thing again.
But maybe the most mind-bending part of this whole story is the time scale. This isn't happening over days or even centuries. A single turn of this cosmic wheel, from magma all the way back to magma, can take millions upon millions of years. So the next time you hold a simple stone in your hand, just remember the incredible journey it has been on. The ground beneath our feet isn't static. It's a slow, powerful, never-ending story. And it really makes you wonder, doesn't it? What will the rocks we see today become in another million years?